Hard constraints. How to keep some of the pieces stuck there without moving at all. We read here network already laid down just to make things faster. It's the same thing we have done in other videos. Just the fracture, Voronoi fracture, and I have the dot network with the packed geometry as the input and the sphere as a collider. So we have some action going on here. We love break things. So what we have to do is go back to the object level and just play and see that everything is falling, even falling before the sphere hits the wall or that box there. And the reason there is absolutely no constraint at all, no glue, nothing there. But let's say we want the edge and the base to be fixed so it doesn't fall at all. So the way we're going to do is first, for each object, we're going to add a point. So I have those points pretty much in the centroid of each one of those objects, and we remove the geometry out of that. And now we can select or create a group with the points that we want to be use the hard constraints. So we want the sides, and we want the base to be a hard constraint. So when the sphere collides, those pieces is not going anywhere. So you can select as you want. You could do it procedural as well. And we're going to create a group. So let's just name it as hard. The name doesn't have any influence at all. And we can blast everything else. So we just select our group there and delete non-select. Beautiful. We have all the points that we want to be permanent, not move at all with the collision. And we can go here in the geometry spreadsheet and see that each one of those points already have the attribute name in there as well, and we're going to need that. Well, what we have to do with the hard constraint is we have to create a piece of geometry that's pretty much in itself. Well, so just imagine that I have a little piece of geometry that is connected to the 2 points that are exactly in the same space. So what we do is we put a clean node there. So now we only have attributes from one side of the piece geometry. And let's put down here connect adjacent points. And that you're going to create the piece of geometry that we need as the hard constraint. Well, I just forgot to put here our merge. So we have the inputs of the 2 node, the 2 points. And if you connect now, automatically we can see because the points on the top of each other, but you can see that it's 78 points and no primitive. And here we have 39 primitives. We expect half of the primitives as we have as the point. So we are on the right track. And we can go in the geometry spreadsheet, and half of them has the attribute name and the other half doesn't have it. Beautiful. Now we have to create the attributes for the constraint. In the previous videos we had used the attribute create. This one we're going to use the wrangle attribute. So this is just a little VEX code, not a big deal. So you just create a string attribute. So you start with s, add constraint name, and it's going to be equal to hard. And I'm going to create another string attribute. So it's a s add constraint type, and I'm going to use our usual all. So it's got a position and also the rotation for the type. So I'm just making it a little bit bigger so we can read it. Those things. Nice. So now every single piece, we can go back and see all of them has a constraint. If you go and put this for primitive, of course. So just putting this as an output. This time we're not going to connect this straight to the second input, but we're going to link to the outside. So just make it nice and put a null there. It's just a good habit to have. and create now our connective network. And drop there, it gives you this usual error, and you can just go and connect with the SOP and drop the hard constraint on the second input, and just drop there hard, and go back to 0 because the length is 0. Actually is hard, not hand, and should work right now. That's that simple. The hard constraint is not hard, it's very simple. That's it for this video. Thank you very much for watching, and until next time.